So here we're going to talk really briefly about atmospheric pressure, and what we mean when we say pressure is the force per unit area applied perpendicular to the surface of an object. And the kind of pressure that we care about is atmospheric pressure, which conveniently enough, if you're at sea level, is equal to 1 atmosphere, which is equivalent to a force of about 1 kilogram per square centimeter if you're considering 1 square centimeter of yourself and you're at sea level. You've got about 1 kilogram of pressure down on top of you. Okay, the second key point is that gases are compressible, so they change volume depending on pressure. So at low pressure, they take up a small volume, and at high pressure, they take up a large volume, and it's at high pressure, if you increase pressure, they compress. The volume that they occupy reduces. So this is just by way of comparison. So this is sort of a figure showing you how pressure changes with depth in water. So you've got water pressure increasing linearly. So this is sort of equivalent to thinking about stacking a bunch of bricks together. So the weight increases as you come down. So the pressure on this bottom bit is a lot more than the pressure on the top, but the bricks don't compress. They stay in shape. But gases, on the other hand, compress. So the brick on the bottom, which is subjected to the most force or the most pressure, compresses the most. So you can think about these as being sort of two maybe pieces of wood with a spring in between them. So the more you stack on top of this bottom brick, the more it will compress. And as you release, as there's less pressure on top of each sort of spring, those springs, the bricks become bigger. Okay, so this is just sort of a different way of looking at that. So here is air pressure decreasing with height exponentially, and it shows you that that pressure compresses the gases so that there are more gas molecules towards the bottom of the atmosphere than at the top. And that's what this orange line here is trying to show you. It's showing you air density decreasing exponentially with height. So that just means that there are more gas molecules here, it's denser down here than up here. Okay, this is just another sort of view of it and showing this air pressure and how it declines with altitude in relation to each of the layers that we talked about in the last video. So you can see that the air pressure declines really quickly, so that it's almost nothing by the time you hit the middle of the stratosphere. Okay, and that's about it.